Precision and recall. Extremely important performance metrics when it comes to building machine learning algorithms. And we all just love plain and simple accuracy, but unfortunately it gives us very limited insight about what is actually going on. That becomes visible when dealing with unbalanced datasets. We can get acceptable accuracy scores with very poor models. So, precision and recall. Let's say we have a binary classifier that predicts if the person has a disease. That means there are 4 possible outcomes. We can predict that the person has a disease and be right. That's called a true positive. We can also be wrong, and that would be a false positive. If we predict that the person doesn't have a disease and we are right, that's a true negative. And if we're wrong about that, we have a false negative. If we calculate the number of those for the whole test dataset, we can create something called a confusion matrix. And this matrix is used to compute a lot of performance metrics. For example, accuracy is simply true positives plus true negatives divided by the sum of all those numbers. Now, precision is explaining what part of instances classified as positive were actually positive. That means we only look at true and false positives and completely ignore the negatives. We simply divide the number of true positives by the sum of true positives and false positives. In our specific case, it will tell us what part of the disease classifications were correct. Recall, on the other hand, is very different. It looks at how many positive class examples were classified as positive. To get it, we take a number of true positives and divide it by the sum of true positives and false negatives. In our case, it would explain what part of disease cases were correctly classified. And that's it. Just to illustrate how important these are, let's go back to our classifier. Let's say we have a test set of 10,000 cases and 200 of those are positive. Our model classified all negative samples and half of the positive class samples correctly. That gives us 99% accuracy, and we correctly classified only half of the positive samples. We did not introduce any false positives, so precision is perfect. But recall shows that something is not quite right. Can you tell why? Of course, it's a very extreme example, but you get the idea. I would encourage you to look at what question the metric answers and choose the right one based on that. And ideally, use a few to get as much insight as possible. I hope you find this useful, and I'll see you next time.